After troubleshooting for hours, I was able to resolve the issue, and actually all I've done is changed the to Ethernet. Somehow my Wi-Fi, the wireless NIC is misbehaving when you connect it to Gns3. So right now, if I come to router 1, show IP interface brief, and so I can be able to ping 192.168.0.1, which is the IP address of my wireless router here at home. Not wireless, as in the router that gives me internet, this Zuku. So in essence, you know that if you were to zoom into this ISP cloud, the first device that you'd find here is the router at home that now connects to the Zuku network and all that. So right now we know that if I try to ping, you see I can reach my router, but if I try to ping 8.8.8.8, that we can never reach that, right? I can even abort. And we know by now, we know the reason why is because you see, routers, before they can forward packets to any destination, they have to consult the routing table, and in the routing table there is nothing 8.8.8.8. so when I ping 8.8.8.8, the packets are getting dropped because the router doesn't know where to send them. So and that's where we need to so you see, if I wanted it to reach 8.8.8.8, I can just do IP route 8.8. Assuming that maybe Google owns the whole subnet of 8.8.8.8, something like that. So we know how we configure static routes, and I'm doing this just to review for those who have forgotten. So we always say the remote network that the router doesn't know how to get to with its subnet mask, and the next hop IP to get it there, because I'm configuring my router 1 and pointing all the traffic to the Zuku router in my cloud there. So I hit enter. Now if I come back and try to ping that, you see it's slow. I don't know why it's that slow. Maybe my internet connection is I had lost power at some point, so maybe it is slow even on my yeah, it's not that good, but not that bad. Yeah, so we can see that we can reach that IP, but now you see and we have seen this static route. So how in the world are we going to develop static routes to every destination? You see, now if I try to ping Facebook, I can't reach it, yeah, because definitely the Facebook IP address, which I can rely on my facebook.com. The Facebook IP address is and we know that Facebook, of course, will have more than one IP, yeah. So of course, if you try to ping this, there's no way we can reach it because there is no Facebook, there is no 150, there's nothing 157 there. So anyway, I think I've belabored on that. So we know that this is where we need to configure the default routes, and we can even remove that one. It have no use. I was just trying to demonstrate that for every remote destination that your router is forwarding packets to, you have to have that route in the routing table. So for the internet, we say IP route. So we are telling the router, you know what, if you want to route, if you get an IP address that's not in your routing table, that is any IP address, zeros is what we say, any IP address that have any subnet mask, that's why we put all zeros, just forward it to 192.168.0.1. yeah, and doing like this is what I was saying, that introduces this this thing of recursive lookup. Because if you look at my static root here, when I try to ping 8.8.8.8, you see for my which was successful up here, the way my router routed that packet is it looked at its routing table and found out, do I know how to get to this? It said, yeah, actually I need to go via this. But then the router asks itself, how do I get to this network? It comes back to consult the routing table again. So then it says, actually I'm connected to that, so I need to send it out F01. So let me ARP. It will do an ARP to get the MAC address of this guy here. So you see how the recursive lookup is happening. The first lookup was when it was trying to forward this packet. It says, I need to take it here. Then it says, how do I get there? I need to come here. So when you're doing a static route with an X-top IP address like this, it's always advisable to follow it with, and this is where now Packet Tracer was not supporting some of these options. And actually what you need to start with is F01. What I'm trying to get at is, let me do a question mark. You can see that you can either use the IP address, what we had used there, or you can start with the, say, fast Ethernet. That is the exit interface. And then you do the 192.168.0.1. yeah, you should always, if you're configuring a static route, yeah, you should always do that. And for the real world, because I've seen, let's say if you have a big network that you have done quite several, you have several static routes, sometimes you see, we are saying that we would like as much as possible to avoid those static routes, right? But see, sometimes it's a necessary evil that you have to put some static routes for whatever reasons. At times it is temporary, because this is where maybe the requirement might be, let's say you have a routing protocol that is choosing to forward traffic out this way, and your boss tells you that we need to forward that traffic over here for whatever reason. Yeah, let's say if you had redundant links, so there you might find yourself using some of those static routes. So you might want to name them. Maybe you say, and names, banners, and all that are things that I like putting them in caps, so that when I show run, I can be able to tell that that's not a command, it's a variable. Anyway, let me demonstrate, you see what I mean. So maybe you can say connection to internet. And I'm confusing with this. First of all, just forget about this part. Actually, I should not write it as a description. The name, or the, anyway, this is the host name. I think I was explaining something different. So anyway, you hit enter. All right, so if you type show IP routes, we can see that we have a static route. And whenever you see the asterisk here, if you come to the codes up here, you can see, where is it? We have the asterisk. Yes, asterisk here is the candidate default, and you can see gateway of the last resort is set, meaning that if I get a packet that is being sent to something that is not clearly defined in my routing table, I'll send it to this, which is the gateway of the last resort. Yeah. and that's what is set here. That's what we call a default route. Because you have put an exit interface, you see we put an exit interface and an IP address. I think this is what I was saying, that packet tracer might not allow you to do that because it's sometimes it's limited in the commands that you can do. Here in Gns3, all the commands that can work on the real device will work here. So about the recursive lookup, now you see my router will not do recursive lookup, because if I ping where was that Facebook's IP address, ping www.facebook.com, it's this one here, copy. So if I ping I can be able to my bad. See what I configured here? I pointed it to the wrong interface, and anyway, maybe it's because of the way that let me first remove that root, IP root. So this one here needs to be F01. Now we ping, we can be able to reach Facebook. Yeah, and you can see this business that I'm doing, that I have to first come to my PC and ping this. I'm sure some of you know why my PC I'm able to ping like this, and so anyway, it's all because of the DNS server, which my quote-unquote virtual router here doesn't have. So in the lab, I said some of the base configurations that we do is disable IP domain lookup, yeah, where we say no IP domain lookup, but we can configure a DNS server. That this is like the way you come to your machine and come change data settings and properties. I'm preaching to the choir here. So you assign some DNS servers here, so that, because otherwise if you don't do that, guys will have to we'll have to browse internet using IP addresses. So you can say IP name server, give it any DNS server that we want. Now we say IP domain lookup, the one that you are negating when you're setting up your devices, when your network is not connected to a DNS server. There is no DNS server, but because now this one is connected to the internet, yeah, and there is so it's just like my PC, which have so now I can say ping www.facebook.com. Yeah, so you can see that it is querying the DNS server, get the IP address, so we can ping www.youtube.com. I mean, we have internet. The router here is live. All right, so my router 1 knows how to get to the internet, and this is what you are calling a stub router, because you can see this network of mine here all the way around, as in it could belong to one organization, and to get out you need to go to the quote-unquote core router. Yeah, the core router. The edge router is what taking, and I'm sure you have seen in the notes, we call it a stub router. So it's the only one that can reach internet, simply because the others, if you come to router 2, if you type show IP routes, definitely it cannot reach the internet. We can obviously see that because the gateway of the last resort is not set. So this is where I was talking about propagating the default route throughout the routing domain, and because here we are still running RIP, you say default information originates, and you do it on your edge router. Yeah, we are on router 1, the stub router, the only one that you need to configure a static a default route. You see, we want to avoid static routing as much as possible. So when we come back to router 2 and you type show IP routes, see the gateway of the last resort is set, and the IP address is readjusted to match what we have here. So router 2, because it had that default information originate using RIP, yeah, RIP update were received by router 2, and it was able to see, aha, it's 65 saying that. Yeah, I'm saying that because if we add another router and it is running RIP connected to router 2, it will adjust, it will correctly adjust this IP address. Yeah, of course that thing have to be logical. There's no way the default root of this guy can be .1 .0 yeah, because this router in the first place doesn't even know how to get to that network. Yeah, it doesn't know how to get to .0.1. But if you try to ping 8.8.8.8 here, we can't ping by URLs. Yeah, we can't ping by domain names because this one still doesn't have a DNS server. Yeah? We need to go to global conf. Yeah, just like what you have done here. That's what I'm trying to say. But you can see the pings here are failing. Why? The reason for that is because now you know that my router here, my home router, this Zuku router here, does not have it cannot even do routing, by the way. You know, these are small, we wouldn't call them industry standard routers like these Cisco routers. Yeah, it's a small router, so it doesn't even do routing. It's not like I can go to it, yeah, and configure some static routes, or I don't think there is anywhere where you can even configure. If we come to advanced tab, where you can configure RIP or OSPF, right? So my router here doesn't know about 192.168.0.1.64. The only other way that I can make it know about it is if I configure the LAN IP. Yeah? Maybe I can change it to a class B subnet or a class A. That way it will be able to include anything that starts with 192.168. But now, right now, basically it doesn't know about this network, all this. So to make it what we can do is now configure NAT. Yeah, we configure NAT for these addresses to be translated to quote unquote my public IP. Yeah, so of course it's private here, but this is what you would configure if you had a real public IP connecting to my LAN. Yeah, and it's not 64 here. I need to change to, so I'm saying the IP address is the subnet that I use here at home. Yeah, so that when I have, if I do IP config, you can see that it's 0.0.0/24. Now that you know how to subnet, you can be able to tell the first usable IP address, the last usable in that /24. Yeah, so this one. So if you want R2 and R3 to reach that, you can configure NAT on this. And as much as we are jumping ahead of what we'll cover in this video, actually I wanted us to look at EIGRP. So that we appreciate. You see, we have looked at static routing, dynamic routing, and this is why we have talked about RIP. I think we have so chapter 9 is NAT and IP version 4. So let's see how we configure NAT network address translation. It's a 4-step process that you need to go through. Actually, I don't know. Is it 4 steps? Anyway, let's see. So first things first, you need to enter. Okay, when I say first things first, it doesn't mean that you have to go in this order. Anyway, I think I need to have my whiteboard so that I illustrate what I'm trying to get at. Yeah, so you need the number so that you can even know the number of steps. So maybe number 1, and I'm saying it's not an ordered, you don't have to do them in this order. So you first create what you call an access list to identify NAT traffic. That is the IP addresses to be NATed. We use an access list to do that. Number 2, you need to let's not call it number, because you can do them in either order. So identify the inside and outside interfaces, that is to the NAT process. And so I said 4 process here, so I think it's actually three steps. You identify the inside and outside interfaces, and then now you do the NAT overload. And this overload keyword is a Cisco, is more of a Cisco term, industry standard, or other people call it NAT and PAT. Yeah, NAT and not stroke. It's NAT and PAT. Because this is where you're turning your router into a multiplexer. So we mean network address translation, port address translation. So using the port numbers, and anyway, I think let's configure it. You see what I'm trying to explain. So with those 3 steps, we can do, and you can do them in any order that you want. But of course, you don't want to, you don't want to apply this 3rd step. You are applying these 2 steps to this. So of course, it would make sense for you to start with either this or this, so that you can apply them here. And even if you apply them, having not configured these 2, there is no harm, only that it won't work. Yeah. As in, it's not like you'll take the network down. Yeah, you can't necessarily. So anyway, we do IP access list. This is how we create an access list. We have not discussed access lists, but I'm actually thinking maybe this was we shouldn't jump, because you see, we are supposed to first look at access lists and what they are. So normally this is like at CCNA level, this is the first basic form of firewall that you can configure on your router. So anyway, we say IP access list, we can say extended, and then we give it a name. We say NAT addresses, and this name, you can give it, you can use a name, a number, whatever you want. And I like named access list because they are more intuitive, as in you know, when you type show IP access list, because you can have many access lists on your device, and you know, in future you might forget what was this access list all about, because maybe if you have configured VPN, you'll apply access list to that. You have configured some QoS, VoIP, and all that. So anyway, you do that, then you can say permit 192.168.1. 0 because we want to permit all the addresses that we want them NATed. Yeah, so you see all this, we can say we can summarize them or supernet. Yeah, supernetting is the reverse of subnetting. You know that we subnetted to get all these /30 slash, but you know that if you come back to the lab, where do I have that lab somewhere? If I can get to it, I think it's this lab2 here. Where was it? So, yeah, so anyway, the one that we subnetted, you know that these guys had a /24, so we subnetted to get all these subnets. Yeah, so anyway, I think you get what I'm trying to say here. So we can summarize them as a /24. So if I do a question mark and I left, you should say permit IP, because it's the IP protocol. Yeah, the thing about access list, this is where you can deny people from using, say, port 80. You know, you can deny the whole subnet, you can deny port 23, you know, limit your users not to use several ports. So the basic tool that you can use is these access lists. So if I do a question mark, you see they talk about wildcard bits. Wildcard bits is just an inverse of the subnet mask. So we have said that our LAN here is so it's 192.168.1.0. The subnet mask is 255.255.255.0 /24. So to get the wildcard masks, you do all 255s, 255.255.255, then you minus whatever subnet mask you have. Yeah, we will see this being applied when we look at OSPF and also in EIGRP, which we were supposed to do in this video, but it seems that so anyway, we minus, so we have 0.0.0.255. so the wildcard mask of a /24 is 250, that one. So if it is a /27, if you want to do these subnets one by one, yeah, if you want to do all of them one by one, all these ones, so for a /30, /27, because you can repeat this command that I'm doing here. I don't know whether you follow what I'm trying to get at here. I mean, a /27 would be 255.255.255.255, then you minus 255.255.255.224. that's a /27. So you'll get 0.0.0. That's a 1 3, yeah, 31. So that's about calculating the wildcard mask. So I'm saying I can .255. So when I do like that, I have taken care of all these subnets. Yeah, that way I don't have to do .0.31, so that I cater for only this LAN here, right? This one here. So if I, for the destination, and this is the source, yeah, all this. So you're telling this access list, please permit this whole subnet. So this is an IP address from the source. So this is source, all of that. Now if I do a question mark, you can see now we are talking of destination. Here when I did source, when I did a question mark, it was for the source. This is for the destination. So for the destination, because it is internet, we say any. Yeah. And now I'm saying I can continue repeating for all the subnets, so I need to change this one here to dot where is that, dot 32. We do again for that. So right now, if I apply that access list, when I hit enter, it will only even have that packet tracer thing. So right now it will only cater for those two. So I'm saying a shortcut, I just summarize or supernet all of them, so that I have dot 0 dot 255. So now if I type do show access IP access list, so an access list is an ordered list, and the lookup happens from, so anyway, I think we will review this when we look at access lists. So right now, this line number 10, it have no use per se, because it is catered by this. Yeah, so in fact I can remove it, but even if you leave it there, there is no harm in it. So we can exit. Now we go to the interfaces. So this is where now we come to our second point here, and my whiteboard is becoming cluttered. Let me change the color. So we have created that access list. So now we identify the interfaces to the NAT process. So we come to interface F01. This is your outside interface, right? Because you see F01, I think I should put this one here. F01 is the interface that connects us to the outside. So we say IP NAT outside. It hangs there because it's turning on packet tracer. It doesn't hang like that, and so you can see that there was a CPU hog. These are what you call syslog messages. So you see, if you have not done logging synchronous, they'll come and they'll mess you up. On packet tracer, I doubt if it will give you all that. So now we go to all the other interfaces, the inside interfaces. So we have F00, this and that, yeah, all those interfaces. So int F00, we say IP NAT inside, and then we go to int S00 IP NAT inside. Inside, you can just hit the up arrow actually. I think we have S01, hit the up arrow, and we have all those. So the second step is done, and so I think we'll still review this because we have gone to anyway, we have jumped ahead. So now we do the NAT overload statement. So we do IP NAT, we say inside. So you see now this is where we needed to identify to the NAT process which interfaces are your inside, because you're telling this router, please NAT from the inside. Yeah, so the router needs to know which side is my inside. Then we say source list, you do NAT addresses, and it is case sensitive. That's why I want to copy and paste it here. NAT addresses like that, and then we say interface. I can type interface F01, and then we say overload. That's why in the Cisco world we call it NAT overload. This NAT overload is what allows, if you don't put the overload keyword, the first device that will be NATed. Yeah, so let's say my PC1 tries to access the internet. Of course it will come here, it will be NATed. So that NAT process or that translation will go to the NAT table. We'll see how we look at that NAT table. So if you don't put the overload keyword, only one device will be NATed, the others will not. But if you put the overload, it means that now that one IP will be, now this is what I'm saying, like a multiplexer. So all these other guys will be able to be NATed. So that overload keyword is important. We hit enter. So now to interpret this command is in English. This is what I was saying, that you're telling the router, please NAT from the inside, use the IP addresses defined in the access list called NAT addresses, and then use the public IP address on your F01 and please overload, meaning that you use port address translation. So to see the NAT table, you type show IP NAT translations. So right now there is nothing because you have not generated traffic. So now if you come back, where did it go? You are trying to ping from, holy cow, we have actually done all this stuff on the wrong router, and I think you guys this whole time you could see that but anyway, no harm. So all you need to do is just show run section IP NAT. Amen. Anyway, I think let me first fix it, then can continue. I have just negated that those commands. Just go to the interfaces, you disable all that stuff. Okay, so now while we tried to ping here and it was failing because we had not configured NAT. Yeah, and I'm now on the right router because I have done all those configurations on the right router. Say, hey, where is this section IP NAT? So I have done overload and all that. So now if I come back to my router 2, try to ping 8.8.8.8, that was failing. You can see that it is successful. Now if you type show IP NAT translations, so you can see that protocol is ICMP. Yeah, so you can see that it was NATed to this, yeah, to .254. So remember when we talked about how encapsulation happens, that you know, where we talked about MAC addresses where they change at every router hop, they keep on changing, but the IP address never changes. Yeah, this is the only exception, because you can see that when you configure NAT, the source IP is actually changing because it came in as this. Yeah, this is the IP address of router 2, right? Because when I pinged, of course the source IP address was .66, that is on router 2. If you come back now to router 1, you can see that it was NATed to this. Yeah, in fact, you see these translations do time out whenever you finish the configuration, that translation. So if you come back now, every device of course now can be able to reach the internet. So if you say ping 8.8.8.8, PC1 is having issues, and I don't know what I misconfigured here. 8.1.0, but that one is NATed. So let's try to ping 8.8.8.8. This one for some reason is not being NATed, or maybe we denied it. Ping 192.168.0. What am I doing? 8.8.8.8. You can see that that one is successful, and we come back. If we come back to my router 1, show IP NAT translations, you can see my NAT table is so you can see that these are the source IP addresses, yeah, the ones that we identified using an access list. So you see this is the source port number. So you see how the translation is happening. This source port number, we say that it is always auto generated, right? This is why we are doing the net start dash n, because we don't want it to give us the, you know, just to give us the port number. So I was saying that you see my PC here, these source port numbers are auto generated, right? Going to a well-known port number, this is the remote side. You see here I'm accessing, this could be the Google server, no, YouTube server, and yeah, which is Google, and this is HTTPS, yeah. So anyway, I think here we are reviewing what we covered in CCNA1 about the encapsulation and all that. So you see when the packets come, yeah, maybe, hang on. So as the packets come, so when I ping from PC3, you know that it is doing that encapsulation, yeah, where we have the source port number, destination. So the packet here would be ICMP, because we are using ICMP protocol, right? So this is the source port number, which we have said is auto generated, yeah. For a ping, we can say that it is uses port number 1, yeah. Then we have source IP address, which is the IP address of so is this dot 62. Then the destination IP address in this case is 8.8.8.8, the one that I'm trying to ping. So we have the source MAC address, the destination MAC address here. So when that packet comes and hits this router, it's being NATed. So you see why we call it NAT and part is because you can see that so what will happen is this source IP address, this of 192.168.1.62, it will be translated using the source port number, yeah. So what will happen is that source port number, let's say that my computer generated 44444, because it have to be above 1024, yeah. So when it hits this router, the packet now will leave the router with this subnet IP, yeah? So it will leave, because my router I have assigned it 192.168.0.254. So when it is leaving here, when you do the Wireshark capture or on that wire, you'll not see the source IP address of this here, yeah, that here. You'll see that's also IP address colon, now this 444, yeah, 4 like that. So that's how, using the port numbers, you are able to do some sort of multiplexing, so that all the IP addresses that are on this wire have this source IP address, yeah. That's what I'm struggling to explain. That's what so okay, so now this is what I was trying to explain, that you see these source port numbers are the ones that are auto generated, but so for the protocol, instead of giving us the port number, it is showing us the protocol. So I can even so when I'm on this whatever, let me try to do a telnet to some IP 8.8. of course maybe it's not enabled for telnet, but either way my whatever you'll be able to. So you can see now instead of ICMP it is protocol. The source port number was auto generated, but the destination port number is the well-known port number of 23. So if I try to go to the browser, and by the using the because here we don't have a browser, you can test using the port numbers. Yeah, let's say 8.8.8.8, we say port 80. Yeah, you put a port like that. If you come back to here, you can see that now we have two translations, one going to port 80. Looking at the time, you'll actually not be able to configure EIGRP on this, but I think now we have been able to exhaust all those base configurations. How we do that default information origin, and I think we did not verify on they're still trying to telnet and all that. So when you type show IP route, we can see that so I was trying to talk about the gateway of the last results that were. So the moment you see the asterisk, it means that's the candidate default. But this one we did not statically configure it. So anyway, I think you'll appreciate this fact when you look at the next routing protocol and you see how we can do the same for EIGRP. So with that, I hope that this has been informative to you, and I'd like to thank you for